Okay, so we're going to finish lesson 32.1 today. We're going to continue our conversation about the unit circle and the coordinate plane. Okay, so if theta is an angle in a standard position, remember standard position means it starts at 0, 0. Its reference angle, this is important, is the angle, actually acute angle, form of the terminal side and the x-axis. So just the x-axis and the terminal side. So this whole thing is really important. So a reference angle is an acute angle, terminal side, x-axis. All right, so here are 4 scenarios. So you'll see here theta is alpha, so just saying your reference angle in quadrant 1 is the actual angle because it's in quadrant 1. Okay, quadrant 2, the reference angle is down here. So alpha is your reference angle. So the reference angle is alpha. Okay, then down here, here's the reference angle. So like here's the reference angle. I'll highlight it like that. Okay, so reference angle, that's reference angle because you see it's the terminal side x-axis, terminal side x-axis, terminal side x-axis. So those are the reference angles. And then it tells you like how to find them. I don't really memorize all these, so I don't know if I'd want you to either, but you can definitely use it as a guide to get you started. So here it's saying like the reference angle is the same thing as theta, and you can see it's the same thing. Here it is, the reference angle is 180 minus theta. So this is theta, take this, the line is 180, minus theta is your leftover. Here it's 180 plus whatever you get right there, right? That's how I do it. Or you could do, they say theta minus pi. That's one way. This one is, the whole circle is 360. So if you go 360 minus theta, that will give you alpha as well. So here's like a little chart you can reference until you get better at it. So here is a little chart to help you out. Okay, so then you guys can read these examples. They're pretty good. So read those examples. And then I'm just going to do a couple of them. So let's do the 4 scenarios. Let's actually do one. So I'm going to make 4 graphs. So let's do, like if we do 63 degrees, draw theta as 63 degrees. So 63 would be, oh, can't see, there you go. 63 would be, well, here's 45, so 63 right there. So this is theta is 63, which is also the reference angle. Okay, because you learned in the top part, it's the same thing. Okay, because it's acute. Now let's do 2 more. Just joking. 3 more. We'll do one in each quadrant. Okay, so this one, let's do 330 degrees and find the reference angle. This one, draw a 240 degree angle, and this one do a negative 120 degree. So this might be a good place to pause the video because what I want you to do is draw these angle measures. Then the goal is to find the measure of the reference angle. So draw the angles, find the measure of the reference angle. So maybe take a moment, pause, do it yourself. Okay. Okay. So hopefully you paused to come back. So 330. Put your pencil, you always start here. It's positive. Since it's positive, you're going to go this direction. There's 90, 180, 270. 270 plus how much more? 60 more. So like right there. So there is a 330 degree angle. So what is the reference angle? Well, the reference angle is the terminal side and the positive x-axis, or just the x-axis actually. So 330, how far does it take you to get back to there? Well, that'd be 30 degrees. So the reference angle is 30 degrees. Okay, there's that one. This one, 240. So 240 would be, it's positive, so you go this way. So 90, 180. 180 plus how much more is 240? Well, 180 plus 60. So there is the 240-degree angle, but the reference angle is the terminal side and the x-axis. So there's the reference angle. Well, what did we just say out loud? We said it was 180 plus 60 more. So the reference angle is 60. All right, last one, negative 120. This is a good one. Negative means you go clockwise. So then you're going to go down. So down is 90. And then 90 plus how much more is 120? So we'll say 30 more, right? That's about 30 more. So there is the negative 120 degrees. But if this is 30 more, how much more does it take to get back to the x-axis? So that's 30. It's going to take 60 degrees to get back to the x-axis. So the reference angle is 60 degrees. All right. Hopefully that makes sense. If not, then definitely email me or come to office hours. All right. Next page. All right. So the unit circle. All that we're talking about here is a good introduction to the unit circle. So first thing I want to do is just draw a quick unit circle here. Well, actually, it's kind of. Okay, so we're going to talk about the angles. So here, we're going to dot a dot there, there, and there. And we've already done this, but I definitely want to review it. So this is 0, right? 0 degrees. This would be pi halves. We've already kind of made the chart, because that's 90. And then 180, we've reviewed is pi. And then 270 degrees is 3 pi halves. And if you keep going full circle, here's 2 pi. So 0 degrees if you're just going this way, but it's also the co-terminal side is also 2 pi. All right. Then it says find the reference angle for each value of theta. So you have 325. Okay, we just did these. Let's do another one. We're going to cross out these. They're all the same thing. I think we're just going to do 2 of them. But I'll be happy to do more with you if you want to come to office hours. I'll do more. So 325, just like the other page. So if you want, you can pause the video and do these 2 and then come back and see if you got the right answer. Okay. Hopefully you paused it and you'll come back. So here, so 325. Okay, so it'd be 90, 180, 270. So 270 plus what is 325? So 270 plus 30 is 300. So 55. Okay, so it's more than halfway. Didn't draw that very well. Okay, so then here is the reference angle. How much more does it take to get back to the x-axis? So the reference angle is 35. Okay, that's in degrees. But let's make sure we can do in radians too. Okay, also I've noticed, take a little side note here. I noticed on your homework that was turned in, please make sure that your fractions are written like this. I'm just throwing this out there, side note. Don't do this. There were several of you, I'm not really sure where it came from because my notes never had this, but I saw this a lot. Do not do that. So this is a better answer. This is a better answer. And this is the same thing, which sometimes it's okay. But when it comes to the unit circle, this is what I want right here. So keep your answers in fraction form like this. No decimals in the denominator. That's not a good way to write your fractions. So not sure where that came from, but I saw that more than I wanted to. So be sure you guys are watching the video and the way that I'm writing the answers. So, because you'll see what we're doing today in the unit circle, all our fractions look like this. So fractions are good. So make sure you practice doing it without a calculator as well. Okay, so let's do D. So D is one way we can do it. There's a couple ways we can do it. So until you get really good at it, some of you might do this. Some of you might say, okay, 7 pi 6. what degree is at. Okay. Also, I noticed, please be sure you guys show your work. Showing your work looks like this. You're showing me that you're multiplying the 180 over pi. This is how you show your work. The homework I just graded was not a lot of work shown on some stuff. So since we're not in class together, I'm really not sure how things are going. So if you could show your work when I'm grading, it'd be very, very helpful. So this is how you would show your work. You would show the conversion factor. Or, side note, if you're doing degrees, you would show like this. This is the conversion factor. Like you're showing me how you're multiplying by this. So this is a better way to write it. So some of the homework I saw, make sure it's complete and I can follow it. Okay, sorry, going off track. Okay, so if you cross out the pi's, 6 goes in 180 30 times. 30 times 7 is 210. So 210 degrees. So if you were to draw that out, 210 will look like what? 210, this is what, 180, 180, oh, 30 more, 210, like that. So the reference angle would be 30. Okay, so all of this is just a side note, okay? Because it's in radians. So if your question is in radians, your answer needs to be in radians. So this was in degrees, so this is in degrees. This is in radians, so your reference angle should be in radians. Okay, so what we could do, I'll keep on this way to make sure we understand it. 30 degrees, here again. How many radians is that? This is how you show your work. 30 times pi over 180. 30 goes into 180 66 times. So the answer is pi 6. Okay, so the answer is pi 6. So this is an indirect way to get the answer. Okay, so you converted it to degrees. I drew the picture. I saw it was 30. Then I converted it back to radians. So radians to degrees, degrees back to radians. Okay, that is one way to do it to make sure we're on the right track. So I know the answer is pi 6. But if I wanted to, let's a better way is to 7 pi 6. So 7 pi 6 is greater than 1 because 7 over 6 is 1 point something, 1.16. So I know it's going to be past 180. Well, looking at the chart, you can subtract what? Pi, right? So subtracting pi is the same thing as subtracting 180 because then you could say 7 pi 6 minus, what's our fraction with a denominator 6? 6 pi 6 is the same thing as 1. So the answer is pi 6. So hopefully you guys are paying attention and following along on this one. So I'm going to say this one more time. So here is radians. So if it's in radians, your answer needs to be in radians. So one way to do it is to convert it to degrees, draw the picture because this is more geometry and it does make sense a lot quicker, and then convert it back to radians. That's one way. Here, once you get better at it and get used to it, well, 7 pi 6 is past pi, so you know you need to subtract 180 or pi to get pi 6. Okay? All right, almost done. Coterminal angles and reference angles can be used to find trig functions for angles in standard form. Okay? Trig functions describe the relationship between sides and angles of a triangle. Very important. All right, very quickly, sine, opposite hypotenuse, cosine. You guys remember this from geometry? Remember, I think your teacher probably wrote stuff like this. Okay, all right, unit, circle, yay. Now we're on to trig. This video is probably getting kind of long. Okay, so it says, you can look at these relationships in a unit circle since the radius of the unit circle is 1. So the radius is 1, okay? So this right here is the radius is 1. So what I want to do is, here is theta, right? Theta is opposite over hypotenuse. Opposite over hypotenuse, right? So it's opposite over hypotenuse. So that's where they're getting, okay, so the vertical distance goes along the y-axis. So this is y. Horizontal distance is your x distance, right? So that's the x-axis, y. So what they're doing is they're doing theta is opposite over hypotenuse. There we go. And then cosine is adjacent over hypotenuse. So adjacent over hypotenuse. And that's how they're getting this right here. So y over 1 is just y, right? So what we can conclude is that sine theta is equivalent to your y coordinate and cosine theta is equivalent to your x coordinate. And that's only on the inner circle when the radius is 1, because 1 in the denominator doesn't change anything. So just remember the radius is 1 on the unit circle. So this is a foundation. So hopefully this makes sense. So this is what you've been doing, that S equals R theta. It's coming from the unit circle. So how I memorize it, like x, y is your coordinate. So x is your cosine. And I do the alphabet thing, x before y, c before s, cosine and sine of the angle. Okay. So let's do a few more examples, then we're done. Okay. All right, last part. Okay. When you're working with degree, just so I don't forget, make sure you're in degree mode. It's important. Good reminder, degree mode. Also, all of these, working with the unit circle, the radius is 1 on all of these examples because it's the unit circle. Okay. Then it says, same thing we just talked about. You can read that. Okay. Find the sine and cosine of 9 degrees. So here's 90 degrees. 90 degrees is right here. Okay. So if 0, 1 is the point, then 0 is my x, right? 1 is my y. So we can say cosine, sine, and that's how they're doing that. They're saying cosine of 90 is 0, it matches. Sine of 90 is 1. And then you guys could do the next question. So it'd be negative 1, 0, that's x, that's y, cosine, sine, and that matches this box right here that they're giving you. Okay, last part. Last 3 questions. Okay, so we're going to do 270 degrees, and then you're going to do negative 270 degrees, and then you'll do 720 degrees. So I'm doing this example right here. Right? Okay, so what I want you to do right now is to find the cosine and sine of each one of these. So if you want to pause the video, that's what I would do. I pause the video, and your goal is to find the cosine and sine of each one of these. So take a moment and pause. Okay, so then let's finish up. Hopefully you've come back. Okay, so 270 is here. 90, 180, 270. Then here, negative, I'm going to go this direction, right? Let's go to draw arrow. 90, 180, negative 270. Okay, this one is what? So it's going to be 360. And then you could go, what, 360. Then I'm going to go around again is 720. So it ends right there. So it's kind of hard to do on paper. It's not two-dimensional, but you're going around twice. Around twice. And it's a coterminal angle, so you stop right there. Okay, now what I would do is, what point is this on a unit circle? Remember the radius is 1, right? Radius is 1. So this is the point 0, negative 1, right? This is the point 0, 1, and this is the point 1, 0. Okay, so what I do is I go like, x, y, x, y, x, y, and then now I can answer the question. So cosine of a 270 degree angle is your x, because x is cosine, 0. Sine of a 270 degree angle is negative 1. This one, cosine of a negative 270 degree angle is 0. Sine of a negative 270 degree angle is positive 1. Last one, cosine of 720 is 1. Sine of 720 is 0. And I will tell you, when you get to pre-cal, you will have to have this memorized. So these points right here, sine and cosine, this is just the foundation. You'll have to have this kind of stuff memorized. So the better you understand it now, the way easier it will be in the fall. So if you have any questions on sine and cosine is your x coordinate and sine is your y coordinate, because on the unit circle the radius is 1. So the denominator is always 1, so it's not going to change the answer to the numerator. So the numerator is just the answer. So if you have any questions, hopefully you guys followed the video. And then the quiz is also on Wednesday. So I will see you later.